The next part of section 9.4 is on quadratic applications, and we're going to focus on one type of application called projectile motion. You'll learn about more in college algebra, but we're going to focus on the most basic one, which is projectile motion, and that is when we launch something in the air, it goes up and comes back down. And it comes back up, down because of gravity, and it shoots up because of an initial force or velocity that sends it into the air. So with 4th of July, shooting fireworks into the air, all kinds of projectiles, throwing a ball in the air, anything like that, it goes up, it hits some point at the top that it will no longer go up because gravity is going to pull it back down. So the general equation, if we're measuring in feet for distance and seconds for time, is h, which is your height. Height is your y-axis. So it's kind of like y equals negative 16t squared. Negative 16 is the gravity force. I'm not going to get into the physics, but we know gravity pulls things down, so that's why it's negative. 16 is a measurement in feet per second squared, which again is physics that I'm not going to get into. T stands for time. Time is your x-axis, so how long it's in the air. And then the v with the little 0 is called v naught, or v null, and that is what we call the initial velocity. That's the force at which it's being shot up. So are you just tossing it? Are you throwing it with all your might? Are we launching it from a rocket? Whatever's projecting it up, that is your initial velocity, and then it slows down as it continues, which again is physics, and we're not going to get into that part. So initial velocity times t plus h with the little 0, and that's called the initial height. So initial height is, am I throwing it from the ground? Am I throwing it from the top of a building? Am I throwing it from my height of my arm? What initial height is it being launched from? Because that also determines how long it will be in the air and how high it will go. So again, just kind of basics. I'm not going to get into the big time physics of it. If you notice, it's like a standard form quadratic with A, B, and C. It just has particular meanings. So we're just going to look at a couple basic examples from the textbook. We're not going to get too complicated here. The first one is from the examples. It says a model rocket is launched from the ground. So from the ground. The height in feet at time t seconds is approximated by the equation h equals negative 16t squared plus 96t. And that's because the initial height is 0, so we would think plus 0, but we don't put anything in there. Find how long it takes the rocket to return to the ground. So I have a little diagram here. We don't need to scale it or anything. We know it starts from the ground. That's the initial height. It goes up to some maximum height, which we don't really need to worry about. And then it hits the ground again at a particular time. So this is not distance it travels, it's just how high it goes in the air and how long it stays in the air. Alright, so we have h equals negative 16t squared. Think of t as x and h as y, same idea, plus 96t. We want to know how long for it to return to the ground, so that h is going to be a 0. So we need to solve for t. How long was it in the air until it hit the ground again? So to solve for t, when we have two terms, the first thing we're going to do is look for a GCF. We've talked about taking out leading negatives, and we want to see if we can take out that 16 as well. So let's see if 96, let me clear that out, if 96 divides by negative 16, which it does. Most of the time your initial velocity will divide by negative 16, and they do that on purpose so that you have easier numbers to work with. So we can divide that out, and it will be left with negative 6. So we have 0 equals, we're going to factor out negative 16. That leaves us with t squared, I'm sorry, try this again. We're also going to factor out a t. So there's a t squared and a t. So we're going to take out negative 16t. That's going to leave us with t minus 6. And that's going to give us two answers, negative 16t equals 0 and t minus 6 equals 0. Well, if I solve this one, I get t equals 0, which we already knew that. That's from where it took off from the ground. And then if I add 6 to both sides, I get t equals 6. That's the other point at which it hit the ground. So it was airborne for 6 seconds. So the question says, find how long it takes the rocket to return to the ground. It takes 6 seconds to return to the ground. Let's talk about that again. I know that's kind of confusing with these applications. They're going to give you the equation. You're going to set the equation equal to 0, so h will always be 0 for these problems. In college algebra, it's a little more complicated, but for us, we're just looking at it being set equal to 0. Then we're solving for t. So the first thing we want to do is look for GCF, take out as much as we can, and sometimes that's all you have to do. Sometimes you'll have to factor after that. For this one, because there was only 2 terms that got it factored for us, we set each variable term equal to 0 and solve. You're going to get 2 answers. One is usually where it starts, and the other one is where it finishes. And so where it starts is not as important. We're more interested in where it finishes. So let's look at the second one. So I pulled this one from the exercises, so you might have one very similar to this in your homework. It says, suppose that a movie is being filmed in New York City. An action shot requires an object to be thrown upward with an initial velocity of 80 feet per second off the top of Madison Square Plaza at a height of 576 feet. The height in feet of the object after t seconds is given by the function h of t equals negative 16t squared plus 80t, 80 is your initial velocity, plus 576 is your initial height. Determine how long before the object hits the ground. So I have another little diagram here. The diagram's just a visual to kind of help you see what's happening. Here's the building. It's getting thrown upwards from the building. It's going to hit an optimal height, and gravity's going to pull it all the way back down to the ground. So this is the ground here. We're trying to figure out what time does it hit the ground. So again, we're going to set this equation equal to 0. We're going to solve for t. The first thing we want to do is look for a GCF, which is always the case. Again, most of the time these divide by negative 16 just to make our lives a little bit easier. This has t squared, this has t, and this does not have any variable, so we can't take out a variable here. We can just take out negative 16. That's going to leave us with t squared minus 80 divided by negative 16 would be 5. T, and then 576 divided by negative 16 is negative 36. The negative 16, you can divide both sides by negative 16 and just get rid of it. Because it's just a value and it's set equal to 0, it really just disappears. If it has a variable attached, that's a different case. So up here we had a variable attached. If it's just a coefficient and it's set equal to 0, you can divide it off and it can just be gone. Otherwise it has to incorporate. So just be careful there, but if it's just by itself, you can divide it off. Now we're going to factor to t minus 9 and t plus 4. So we get 2 answers. T equals 9 and t equals negative 4. Now we're talking about actual real time. So 9 would be 9 seconds. 4 being negative 4 does not make sense in this situation. So it does not fit the situation. And that's because it's being launched from a building. If you see, I kind of let the parabola continue. If you were to continue it backwards symmetrically, it would hit at -4. But since we only think of time as positive, we don't think of time as negative, that's why it doesn't make sense. The 9 is the one that makes sense. So your answer would be after 9 seconds. So you're either going to get 0 and a positive number, so the positive number is your answer, or you're going to get a positive number and a negative number, and the positive number is the one that's reasonable given the situation. So that's just a little bit of an introduction on projectile motion. You'll have 1 or 2 of those on your homework, but it's something you'll dive into much deeper in college algebra.